this. So sorry I didn't post this in Piazza, but I thought that was brief enough. When is the due date for final reports? The due date for your final reports is the last Sunday of week 6. Yeah, last Sunday of week 6. So I don't have a calendar in front of me, but last Sunday of week 6, which, you know, is basically the end of this month effectively. And basically midnight. You can submit at any time that time. If I need more time to complete the project, will I be able to do that, or will I have to submit on the last day? So just in the interest of us being able to manage the workload, we are requiring you to submit your final report on that Sunday if you want a certificate of completion. All right. And I don't want to make this sound like it's a free lunch. It isn't a free lunch. In that we, you know, as long as we see that you have captured the work you have done in a good report, we'll more than likely give you a certificate of completion. Now, if you would like to do additional work afterwards, and would still like our feedback on it, feel free to do that work. Feel free to submit it. But I can't guarantee that you'll get any necessarily feedback on it or response, just by virtue of the fact that obviously we will be beyond the official timeline of the project and have other responsibilities present. So, but by any, you know, you still have the pies, you still have all the material. Don't stop if it interests you, right? Don't. But if you want that certificate of completion, we're gonna hold to that Sunday of the 6th. My recommendation would be at the start of the 6th week, take inventory of what you've done, and start writing a final report for that, right? And even if it feels like you haven't gotten through everything you'd like to gotten through, it's better to have a well-formed report about what you've done than nothing at all. All right. At least that way we have an artifact by which to say you deserve the certificate of completion. Do we necessarily have to explain terms like beacon? I mean, who is our audience? Well, here's a good what I would say life lesson for those of you who are planning to become technical or, you know, professionals in science or engineering or other technical fields. You should always assume, all right, unless you're talking to explicitly a room of your direct colleagues, people you work with day in and day out, you should always assume that you're going to have to explain the core topics. And explain is very loose, right? It's not like you had to write a small essay on what a beacon is. You can cite something else to say, here is what a beacon is, or you can describe it very generally, right? A beacon is a way, is a Bluetooth mechanism by which a device can advertise information. More details can be found at this reference, right? But you do need to provide folks the reference by which to go learn enough, because the way I think about it is it's a bad example for me because my grandparents have PhDs, but or had PhDs, but I always say, and it may be a little presumptuous, but just pick a family member in your family member who doesn't do research, who isn't technical, and just imagine you're explaining to them, right? How would you do that in a reasonably concise way? You would more than likely send them to a reference after doing some very high level explanation. Okay, let me just see the rest. Okay. If final report or the student's work will be evaluated as inadequate, can the certificate be canceled as such? Okay, so we won't cancel any certificates. We just won't award them. And trust me, again, not trying to say it's a free lunch or the bar, we're saying the bar is so low, but really, it's about showing that you made an honest and believable effort and that you captured your work in a reasonably well-structured, well-written report. That is, there's no, this is a pass-fail sort of thing. So, we're looking for good English, clear writing, logical thinking, things that you would apply to any schoolwork you do. Trust me, the vast majority of you who do an honest effort will get a certificate of completion. I wish I could be more definitive than that, but at the end of the day, we're not going to cancel anybody. It's just that if you turn in like a single paragraph thing that says, I collected some data and my hypothesis was true, then yeah, that's probably not going to qualify as meeting the threshold. All right, see a few questions related to, we'll get to the top upvoted ones later, and the other two I'm actually going to address. All right, so citing outside code. So this goes to also citing sources as well. So somebody asked, how should I cite code that I'm leveraging with or without modification? So first thing is cite the code, presumptively open source code, according to whatever, if any, license is associated with that code. So whether it be MIT, GNU, BSD, whatever, just follow their license. If they say thou must cite our code and include this disclaimer, then that's what should go in your code. And so that's specifically about citing inside of code, right? It's inside of your source code. So, and on top of that, when you're citing inside of code, you'll want to state the usage of that code and the file /class /method doc string, wherever it's relevant. And a doc string is basically, that set of comments that explains what this block of code is doing. And that block of comments, you may have a references section and you say, this code leverages this open source code with or without modification, all right? And you'll want to point a URL to it, and that's usually sufficient. When you cite code and also other sources in general, like, documents, journal papers, whatnot, use whatever citation style you're comfortable with, whether it be APA, MLA, or Chicago. Just be consistent, use the same style, and cite, and specifically when it comes to code, cite it as a website. But for documents, for books, for whatever, cite it according to the, the standard stylistic. The reference code does have a license size, just completely open MIT license. So you can actually see it in the repo. I didn't actually put it in the source code directly, but I'm not picky about it, right? I'm the author. I technically own this because I wrote it off hours. So that's fine. I'm not going to care if you don't it's PiPact. We know where that code came from. All right. All right. So the last question is about ROC curves, and then we'll get to the other two questions are still up. So is an ROC curve required? Okay, so first, the generation or inclusion of an ROC curve is not required, but is recommended if you're evaluating a detection algorithm which has parameters you intend to vary. So remember, an ROC curve is designed or intended to show and illustrate how the performance of your approach or your algorithm varies as a function of parameter or configuration choice. So you have some dial on your algorithm you can turn, right? Like the volume knob on a speaker, you know? If you turn it to 0, you know, your speaker / your algorithm does this. If you turn it to 11, that's a Spinal Tap reference. Sorry, that's just how I always refer to things. If you turn it to 11, your algorithm does this. Then the RC curve is designed to illustrate exactly what the performance is at all those all the relevant settings. So obviously, if you are not doing, if your hypothesis has nothing to do with actually evaluating a detection algorithm, you don't need it, right? There's nothing to show. You know, you're focused on data analysis, for example. But we recommend you use it because an RC curve conveys a lot of information very directly and without ambiguity, right? Just imagine trying to explain a couple of dozen different performance points and how they relate to each other, right? That, you know, that if I change the parameter by this much, that the performance changes in this way. If you want to describe that in words, you know, or with another type of graph, then you can, but in my opinion, you're probably going to be doing a lot more explaining. But you're going to have to be very precise, right, about the exact relationship or linkage between whatever statements you're making and the evidence you provide, right? So that if you say that this is how these two performance points relate, you know, related to this variable, you'll have to present that very clearly. Now, in terms of generating the RC curve, you can do that with almost any standard plotting tool. We've just put forth a couple of free ones, and then Excel. I had MATLAB on here, but I took it off because MATLAB licenses are stupidly expensive, and nobody should be buying one for this course. So, you know, there's a couple of Python options and matplotlib and scikit-learn. So, and I know both references to scikit-learn, but the top one is actually, all it does is it uses the matplotlib reference. All it does is generate the data, the true positive rate and the false positive rate using scikit-learn, but then plots them using matplotlib. You'll see that in the example. While the scikit-learn reference is directly a function that you can put in those variables, true positive rate, false positive rate, and it'll generate the curve for you. Scikit-learn underneath it still uses matplotlib. So they're basically doing the same thing. And then if you want another option, R is an option. You could also use Octave. I didn't put it there, but R is an option. And then you can obviously do an Excel. And there's a pretty decent Excel YouTube video about how to do an Excel. But basically it's X versus Y. That's all it is. You know, the X-axis is false positive rate. The Y-axis is true positive rate, or, you know, true positives versus false alarms. And then there's a couple of guides here about how to actually create the curves from the data. I guess a little bit more actual guide, right, where you can read and follow along the steps. So there's a pretty nice one from Google though as well. There's a nice this is a specific link in a larger section, and the larger section may be useful. It's a section on classification, as you can see here by the hyperlink hierarchy. So that would be that's a pretty good tutorial. All right, so I have two questions left here. So can we still have a hypothesis reviewed in case we have other ones that we find interesting? So first, I want to apologize to folks who have sent us hypotheses that we haven't reviewed yet. We're just chewing through the backlog. There's a lot of them. You guys have some interesting ideas. We want to give you good, honest feedback, so it just takes time. So hopefully by tomorrow, I'd imagine we'll have answered all of your hypothesis requests. But to the question at hand, we'll have to sort of play this by ear. I'm going to commit to being as responsive as possible throughout the whole course. So if you want to modify your hypotheses, if you want to think of new ones, feel free to send them along. But you should do so from this weekend on without the expectation that they'll necessarily be answered promptly. Not that they have necessarily been thus far, but you know, you want to calibrate yourself to the fact that you just may not get an answer. We at some point have to put our efforts and resources onto the other things, answering questions, prepping the final report, getting ready for the end of the course, so on and so forth. Okay, can we send emails asking for pointers on our project? I just sent an email asking for opinions on my experiment, and I still have not gotten a response. Yeah, you can send us emails to PiPact. I would also say, unless you are concerned with divulging, you know, secret sauce, or you're just not comfortable sharing with your fellow PiPact participants, putting your questions into Piazza is a great way to ensure you get some feedback, even from other participants, right? I know you guys might have an expectation that we have all the answers and the definitive answers, which is by no means necessarily true. But you know, we're knowledgeable, we're experienced, and we do, you know, that should mean something. It does mean something. But your fellow participants also are very intelligent and can oftentimes, you know, shake something loose, right? Sometimes your question requires just a different way of thinking about it, and that different way can come from folks who are not the instructors as well. So I know who you are. I will get you an answer shortly. Again, just a backlog. But I would also recommend that you post things in Piazza as long as you're comfortable, but we'll answer email. So when submitting our final report, should we attach a Jupyter notebook containing any analysis we did? You do not necessarily need to. It's always nice to have that as a reference artifact. So remember, you're going to be submitting your final report and your data to the Google Drive. And you can submit any other artifacts you want there. So there's no requirement to submit a Jupyter notebook, but we will obviously, that will go along, that for example, would go a long way in describing your analysis, right? Rather than what I would say, like detailing all the like technical and mathematical and statistical and analytical steps you do, you can sort of give the broad strokes of the approach and leave the details for the Jupyter notebook to explain. Obviously, though, I want to emphasize that, like with any code, right? In order for code to be qualified as good, in my opinion, it needs comments, right? It needs some level of comments so that, you know, somebody isn't just sort of reverse engineering your intent from syntax. And that goes towards the Jupyter notebook, right? If your Jupyter notebook is a series of steps that execute an analysis, then the comments explain the steps, right? They explain what this step is supposed to do, unless it's so self-evident from the syntax. But you know, there's no golden rule for that, as anybody who's written code knows. There's no golden rule for what qualifies as good comments. What qualifies as bad comments is none. That much is a golden rule. So so there's your trade. All right. So but we would definitely I think it would go a long way in qualifying your report as being a good report. You know, it's a balancing act, right? We look at the sum of the whole, not just that every single section needs to be perfect. You know, maybe you're a little weak in some area, but very strong in other areas that will help make the product, the final report, look on whole sufficient, if not good. All right, so I don't have any more questions, so this might just be a short Q&A session. No need to hold everybody up for an extra half an hour. So I will remind everyone that we're coming up on week 5. I know a lot of you have just started your BSWI courses, the other courses, and you're getting extremely busy. Just do the best you can to balance everything. If you want the certificate completion, we will need a final report at the end of week 6. Just you'll want to define the scope of your effort, right? So you can meet that delivery. So if you need to scale things back, scale them back, all right? We're not going to necessarily hold that against you. And a few more questions are streamed in, so I'll answer these 2, and then I will sort of close the session. So can you give us another example of a good hypothesis? Oh, that's a that's a broad question. So I'll give you an example from maybe a data, sort of a phenomenology standpoint, right? Not one that's focused on the detection algorithm, more like almost like a basic science question, right? So one might be, all right. So there's a phenomena called multipath. All right. And here's a little. Actually, let me try to find an example of it while I'm talking. So there's a phenomena called multipath that is basically almost akin to echoes, and it combines in combination of the notion of echoes with constructive and destructive interference. And I'm trying to find a better picture of it. Let me try. Okay, this'll do fine. Alrighty, let's share this screen. Here we go. Oh, here we go. Okay. So it's a little small. Okay, so multipath. All right, so multipath is this notion that if you have 2 antennas, you have a transmitter and you have a receiver, right? Or you have a transmitting device and you have a receiving device, that the signal that gets transmitted, the most direct path or the line of sight path is the straight line path, right? From one device to another. But that's not the way the signal actually gets sort of emanates, right? It's not like a laser or a very narrow signal spatially. It actually is very broad spatially. It transmits in all directions almost. So those additional directions, that signal will bounce off of things. Like sound bounces off of walls, or light bounces off of material, or specifically like mirrors, for example. And some of those bounces will actually still arrive at that receiving antenna. So the notion here is that sometimes, right, it's the same signal, but in terms of multipath, one of those signals took longer to get there than the direct path. And so the receiving device hears both of these things, but they're not necessarily what we call in phase. All right. And let me find so there's a Wikipedia article, and this image is this image is what's important. So like the red line might be the direct path, and the blue line is that bounce, And so when you add these 2 things together, sometimes, for example, you see right here, maybe you see, if you can see my mouse, towards the left, you can see sometimes a negative value of the blue adds to a positive value of the red. And so the overall signal is actually weaker. All right. And so that's what's called destructive interference. And so the question, one hypothesis might be, does multipath interference exist with Bluetooth devices, or in this PiPact construction? And you have to read a bit more about it. But bottom line is, if we go back to this image, this is all Pythagorean theorem, right? Like, what is the distance of this path is all Pythagorean theorem. So depending on the height of the antennas, the distance of the multipath changes. So the experiment you might want to run is having the pi's at different heights and seeing when, but at the same distance, right? So, and seeing when the signal seems to change, right? When it gets noticeably weaker, right? Obviously, by shifting the distance, you're shifting the height. You're changing the distance marginally, but you're going to see a much greater impact when multipath interference actually occurs. So that's an example of very precise, what I would say, a very specific Q hypothesis that's very sort of finite. And I went on a little technical monologue there, so apologies. But a good hypothesis is something finite and tractable, right? That you can actually do an experiment behind. And then the last question, which disappeared for some reason.
Sorry, my bad. It's in the answered ones.
Oh, okay. Yep.
How you collect the PDF values for the histograms again, please?
Yes. Okay. So, so the PDF. So all this is. Let me try to find. Trying to do something here. Let me get this up. There it is. Good. Okay. All right. So I hope everyone can see this. Trying to zoom in, but it's not letting me zoom in. There it is. Okay. All right. So you collect data. All right. You collect data using this, using the reference code or what else. And so what you get is a set of samples, right? And for every single one of those samples, you have an RSSI value. So I have sample 1, 2, whatever, yada, 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 right? And so on and so forth. So you collect whatever number of samples, and here, there's different values here, and I'm just gonna, this is entirely incorrect, but let's just, because I don't want to be typing random numbers, but for every single one of those samples.
I don't think we can see your screen, remember? The multipath is still up.
Oh, my bad. Give me 1 second. Okay, so I hope everyone can see the Google Sheets now.
Good to go.
Okay, so you collect data, and in that data you'll have a set of samples, right? So I have 25 samples here, and for every single one of those samples, I have an RSSI value I collected. All right, associated with that sample. All right, so this is 25 samples with some. Well, these are all, just linear increments of 1, but, your data is going to be a little different. Let's just make it a little different just so the histogram doesn't look completely insane. Okay, there we go. All right. So how do you convert this to a PDF or a histogram, right? A histogram, all it is counting how many times a value occurs within a given range. All right. So those ranges are called intervals or bins. All right. And so the bins are actually sort of ranges of values. So here I might describe one bin as going from -45 to -44 inclusive. And then I go from -44 to -43, and so on and so forth. All right. So in this bin, I have this value, but I also have this value. So how many times did that occur? All right. That occurred 2 times. All right. And then this bin, nothing occurred because I'm going in the other direction. So nothing, 0. So you create whatever number of bins of whatever size you want, and it basically counts how many times a value occurs within that range, within each of those ranges. And then all you're doing is saying this is the frequency of occurrence within that bin. Now, if you'll give me a second, I think there is a histogram feature. Nope, that's not right. That's a chart. And this is where my this is where having here we go. So for example, all right, this is the histogram. It's decided to arbitrarily bin things from -70 to -64, -64 to -58, -58 to 52, so on and so forth. It created this many bins, all right? And you can see, and the value in here is the count, all right? So obviously you can do all this manually, but most modern plotting tools have this. So your goal is to create this set of entries in a spreadsheet of some sort, or data or a matrix, and then you use a histogram plotting tool to why can't I see there it is, to create you know, whatever histogram you want. So here I changed the histogram bucket size to be 1. You know, so that's again every single one. You can see here they're all 1 except for a few. You know, I could, if I change it to 2. So this is just in sheets, which you guys could use. So that's, you know, and there's plenty. Trust me, if you just Google how to make a histogram, you'll find no shortage of how you convert a table that looks like this into the histogram. Okay. So, all right, I'll answer this last question then, really, that's it. Okay. After we make the histogram in sheets, how do we do the critical value stuff, etc.? All right. So for this, it's actually easier to reference the previous the discussion from this week. So I'm going to open that up and share that screen. Okay, I hope everyone can see that. So we're going to scroll down to this. All right. So I've made some fake histograms. One is the histogram of the data associated with data that was collected at distances greater than 2 meters, this orange one. So this is when the pies were at more than 2 meters apart. The blue histogram is for data when the pies are closer than 2 meters, right? Picking the critical value, right, is saying that relative to for this value, or for this critical value, when I see a value greater than that value, I will declare H1, where H1 in this case is being within 2 meters. And when it's less than this critical value, I will declare H0, or that it is greater than 2 meters. How you choose that is a matter of what types of errors you want to how would I describe it? Tolerate. All right. So in a perfect world, all right, or in a perfect world, these two histograms would have 0 overlap. You can see that these two histograms in this region here, down here around -50 to -30, you can see they overlap, meaning that there are RSSI values which can occur both under hypothesis H0 and under hypothesis H1, meaning that you cannot uniquely associate with that RSSI with a hypothesis. There is some confusion that could occur, and therefore an error could occur. All right. So what types of errors do you want to tolerate? Now, remember, in this case, H1 is when we are within 2 meters and H0 is within or outside of 2 meters. So if I declare H1 is within 2 meters, in our PiPact COVID tracing intent, our goal, we are declaring that someone is too close, right? It is effectively a positive declaration. So if I make a false positive, an incorrect positive declaration, I may be causing a person to incorrectly go into quarantine, right? Because I incorrectly declared that they were too close to somebody who had COVID-19. All right. On the other hand, if I see a value, right, that is actually for H0 greater than 2 meters, or is actually for H1, is actually for H1, but I declare H0, that's called a false negative, right? That means I should have declared them as being too close, but I didn't. So we've let somebody continue out into the world who may have been, maybe carrying COVID because they were in contact with somebody who had COVID. So what is the risk associated with either of those, right? The risk on one is with making a false positive declaration, that sort of error, is that we are causing somebody to go into quarantine incorrectly, and therefore we are affecting their lives in a significant way. And we're causing stress and whatever, et cetera, et cetera. On the other hand, causing a false negative, right? We're letting COVID persist, right? We are not breaking the chain of transmission, and that's obviously has more public policy, public health impacts than any personal. In addition to obviously the personal things, right? We want that person to get treatment, potentially get diagnosed, and if they need treatment. But there's the public policy, the public health question. Those things are not for you guys to necessarily declare. That is why, right, when you pick a critical value, you are picking just one performance point and declaring what the performance is in a way that lets you draw that point on an ROC curve. And then if you do multiple points, you can see where the options are, right? Therefore, with this curve, I, as the public policy expert, or as the guy making the decision about which version or what the critical value we should use, I'm picking it based on the idea that this, I have a certain requirement for, like, I need to see at least 90% of the cases, right? But I can't tolerate more than a 30% false positive rate. So this performance point, this green point, is good, right? But if on the other hand I need a 90% point, but I can only tolerate a 10% false positive rate, then there's no point on this curve that works, and we need to go redesign the thing. So that's the answer, right? Is you're not picking something to aim for, like, the end solution. You're picking something in multiple critical values, if that's your approach, to describe the overall regime of performance your algorithm has. So that may not have been the most straightforward answer, but the bottom line is that you have to explore, right? There's no set formula for how to do this. If there was a recipe on how to pick this value without any ambiguity, we would do that, but there isn't. So welcome to the real world. And with that, I see one question here in the chat. Just FYI, it should go in the Q&A. Could a box and whiskers be a good alternative to histogram? Absolutely. It conveys the same thing. The tricky part about box and whiskers is that if your x-axis is the hypotheses, then you only have two, and you may be losing, right? You don't necessarily see the amount of errors you're doing, right, in the same way a histogram may convey, right? It may not be as reflective of or help you inform decision points if you're doing a decision algorithm. but a box and whiskers is good too. Just, these are all tools. Use what you need. There's no one killer graph, one killer presentation, one killer methodology. It is really just bring it all to bear and be very deliberate and methodical about collecting the evidence to make your decisions. All right, and so with that, I'm going to say, the fourth week Q&A session is concluded. And so if Lisa or Joel have any additional things they'd like to state.
I just wanted to let you know, Dr. Emily Shen will be the speaker Monday, and her talk will not be recorded. So try to make sure you can get there if you can.
Yep, we'll send out a.
I just sent.
Okay, great. Then we're all sent.
Well, is the next Q&A session on July 19th? Or when is the next Q&A session?
Next Q&A session is next week, Friday.
Okay, next Monday, okay. Or next Friday.
Next Friday. Yep,
Okay,
we have Q&A sessions every week. This next discussion will be not this coming Monday, but the Monday after that. So a week from the coming Monday.
Okay.
Great.
All right, everybody. Thanks for tuning in on Friday. Hope you all have a good weekend and have some fun with the project. And yes, we'll get back to you on the hypotheses and that question about your data. Just give us some slack. We're a small team. So thanks, everyone. Have a good weekend.